milliliters of 0.717 molarity potassium chloride aqueous solution and mix it with 55.6 milliliters of 0.768 molarity lead nitrate. And this should be a 2. Due to the space, it got carried down to the next line. But how many grams of lead 2 chloride can be formed? And you've got your balanced reaction right here. Let me take some notes on this. It's 82 milliliters of 0.717 molarity potassium chloride and 55.6 milliliters of 0.768 molarity lead 2 nitrate. And the question is grams PbCl2. And this is a double replacement reaction. And in this reaction, we are making a solid, and solids, we tend to think of them in terms of grams. And aqueous phases, we tend to think of those in terms of milliliters and molarities. So I've got all my notes now, except for my balanced reaction. And I'll write that down real quick too. PbCl2 plus KNO3. And there's a 2 and a 2 there. And that's just a scribble. My apologies. Okay, so what we said about limiting reactant problems, and this is definitely a limiting reactant problem, is that you get a volume, and a molarity, which is enough information to find the moles of potassium chloride. We get a volume and a molarity, and you can find the moles of lead nitrate, lead 2 nitrate. So that means we do both. I'm going to start with my milliliters, and I'm going to start by moving the decimal point 3 places. To turn them into liters, I get 0.082 liters. I notice that my molarity of potassium chloride, molarity stands for moles per liter. I break those up to 0.717 moles of potassium chloride per liter. So all this is the molarity right here. Then I need a mole-to-mole conversion. I need to turn my moles of potassium chloride into moles of lead 2 chloride. I see that it takes 2 moles of potassium chloride reacted for every 1 mole of lead 2 chloride produced. And then for lead 2 chloride, I need to hit my periodic table, and lead is 207.2 plus 2 chlorines, 2 times 35.45 straight off the periodic table. 1 mole of lead 2 chloride is 278.10 grams of lead 2 chloride. We did it once, we'll do it again. Now starting with my 55.6 milliliters, and I'll do this in another color. To convert milliliters to liters, move the decimal point 3 places to the left. Yep, let's take that away. We'll do that up here. My molarity is broken down similarly. 0.768 moles of lead 2 nitrate. This time I have 1 mole of lead 2 nitrate on the bottom for every reacted for every 1 mole of lead 2 chloride produced. And then my last step is the same. And again, I almost run out of space. All right. Are there any questions about this setup? If so, jump in any time, but I'm going to start doing the plugging and chugging, as they say. 0.082 times 0.717 divided by 2 times 278.1. And I get 8.18. And my units are grams of lead 2 chloride. Now let's do it for the other one. 0.0556 times 0.768 times 1 divided by 1, so don't do it, times 278.1. I get 11.9 grams. And when you get to this point, it's always the smaller amount, which is 8.18 grams. And that's what we're going to enter in. It does ask for grams. Good. I always like to reread the question. And lo and behold, we got it. Excellent.